Last page. On this page, you might want to consider making the entire BCA table. And the reason is that this one balanced reaction that's already up there is going to apply to the next three sets of problems. They're going to ask you a little bit about two of the products and also about the amount of heat. So you might want to just consider making yourself a BCA table. And we can even put the BCA table over here. That's how I'm going to do it. Of course, when we're all done, we're going to have none of this stuff left and none of this stuff left. At the very beginning, we're going to have 0 of this, 0 of this, and 0 of this. And our mission is to figure, we could go from there. And why this will work is because every single one of these, it says 35 grams of octane, 35 grams, 35 grams. So first things first, we're going to need to know, with 35 grams of octane, we're going to need to know how many moles of that is. Well, 1 mole is 12 carbons is 96, plus 8 hydrogens is 104, 104 grams. 35 divided by 104 equals, okay, I did something wrong. This is H18, so it's 114. .35 divided by 114 equals 0.307 moles. We are going to have 0.307 moles, and if we use it all up, we'll have none left. We are going to need to figure out how much carbon dioxide I'm going to get. Well, 1 mole makes 8 moles, so we're going to need 8 times as much. 0.307 times 8 times 8 equals 2.46. 2.46 moles. They're going to ask us about water on one of them. 1 mole of octane makes 9 moles of water. 0.307 times 9 is 2.76. And they're even going to ask us about energy, which is in kilojoules. 1 mole releases 5,483.4 kilojoules. So 0.307 moles will only release, and so if I'm going to fill this up there, I think that's really one of my problems. How much energy is released? 0.307 moles of C8H18. 1 mole of octane, C8H18, releases 5483.4 kilojoules. I'm getting that from the balanced reaction. I'm ignoring that negative sign. There's no such thing as negative energy. The negative just tells you that it's being released and it leaves the system, but we don't calculate it, otherwise we'd get a negative, we don't need a negative number. 0.307 times 5483.4, that's going to be 1683.4. 1683.4 kilojoules. That one's done. 1683.4. How about the next two? With the how about the one about carbon dioxide? They want to know how many grams of carbon dioxide are formed. Well, we know that we're going to get 2.46 moles of carbon dioxide, and 1 mole of CO2 is 44 grams. 2.46 times 44 equals 108.24 grams carbon dioxide. Number, unit, label. And the next one, I'm going to use a little bit of information on here. Remember all this stuff? Well, we got past that. We ended up using Puvnerts. It's just a easy way, mathematical way of being able to figure out what the pressure, the volume, number of moles, or temperature will be given the other variables. So I'm not going to use all the arrows or anything like that. When I go to here, I'm going to use that idea of PUV-NERT. And they give me all kinds of information, but there's a few things I have to remember. How many liters of water vapor are formed when 35 grams of octane? Well, we already figured out that water, we're going to have 2.76 moles. So our number of moles is 2.76. The pressure, 1.05 atmospheres. The volume, well, that's what we're trying to figure out in liters. Set that equal. The R value is 0.0821. The temperature, careful, it's 28 Celsius, but we got to remember to add 273. If you need Kelvin, you have to add 273. So that's going to be a 301. Divide by 1.05. What you do to one side, you have to do to the other. And your answer is going to be 64.96 liters of H2O. Number, unit, label. Last couple. When you see something like this, it's usually written P15, 31 above each other, or staggered is okay. You have to break down how many protons, neutrons, and electrons. Protons, that's just the atomic number. It's 15. It's right there. But its total mass number is 31. So 31 minus 15 tells you that there are 16 neutrons. And if it's neutrally charged, that means that there's no more positives than negatives. Then it's got to have the exact same number of electrons as protons. So by definition, a neutrally charged phosphorus is going to have 15 electrons. Finally, an unknown metal has two isotopes based on mass spectroscopy. One isotope is 50.69% abundant. Mass, okay. So this is one where we have to figure out what the atomic mass is for the element and then check the chart to see what element it is. We could probably just look at the two numbers and figure out what element it is, but how do I calculate? If 50.69% or 0.5069 when you write it as a decimal is 78.9183, and the other 49.31% or 0.4931 when you write it as a decimal is 80.9163. When you put that into parentheses carefully, you're going to get 79.9 AMU. That is the atomic mass for the element, and so therefore it has to be bromine. If you look around at all the elements, the only one that has an atomic mass of 79.9 is bromine.